Dear students, let us to discuss some numerical questions on motion in a plane. The question is, vector A is equal to 3 units. Vector A equal to 3 units. A vector A equal to 3 units acting along east, and vector B equal to 4 units acting along north. What is the magnitude of their resultant? Okay, see, I think already all of you know about the direction. See, if you are facing towards the board, your right side is east, so definitely the opposite one is north, west, and upper one is north. Okay, so these are the directions: east, west, north, south. Okay, so now let us to draw these two vectors in geometrical form. Okay, so now the first vector A equal to 3 units. See, start from here. A equal to 3 units acting along east means towards east. You have to draw towards east. So this one is the first vector. Okay, yet you can say the line PQ. The line PQ indicates the vector A. Next, another vector B. Okay, at 4 units acting along north. Okay, so for this vector A equal to 3 units, its initial point is A, P, and terminal point is Q, and you have to start the second vector from the terminal point of the first vector as the initial point of the second vector. So this one is towards north, okay, which is 4 units. So this one is the vector B. Okay. So now the angle between these two vectors, that is vector PQ and vector QR, is 90 degree. So the resultant, okay, what is the magnitude of the resultant? See here, the resultant equal to sum of these two vectors, that is vector PQ plus vector QR. See, the direction of PQ towards east and the direction of QR is towards north. So vector PQ plus vector QR, we can write it as vector PR. Vector PR is the resultant of these two. Okay, so this gives vector A plus vector B, taken in reverse order. Okay, so definitely we are getting the right angle triangle as per the triangle law of addition of two vectors. If two sides means two vectors are taken as the two sides of the triangle taken in order, and the third side taken in reverse order, gives magnitude and direction of their resultant. So therefore the resultant of these two is vector PR. Vector PR means vector A plus vector B. See, magnitude of vector A plus vector B is same as magnitude of vector PR. This one is the magnitude, this one is the vector PR. Is simply PR. The length of the line PR is the magnitude of the resultant of two vectors. See from figure, so the length of the line PR is square root of 3 square plus 4 square. So that one is 9 plus 16. So this one is 25. So under root 25 means 5 units. Okay. So this one is the magnitude of resultant of A and B. The magnitude of resultant of A and B. Okay. So note on this. Okay, the next question is, what is the magnitude of vector A equal to 3 I cap plus 4 j cap? See, here I cap indicates the direction. Okay, I cap and j cap are the unit vectors. I cap is the unit vector along x direction and j cap is the unit vector along y direction. Okay, so here there are two vectors A and B, or you simply can say xi cap plus yj cap. See, we know that if vector A equal to A1 I cap plus A2 j cap plus A3 k cap. This is the spatial vector. Spatial vector means the vectors lie in space. Okay. So then the magnitude of the vector is square root of A1 square, A2 square plus A3 square, where A1, A2 and A3 are x component, y and z components respectively. Okay. So now here the magnitude of 3 I cap minus 4 j cap equal to square root of 3 square plus minus 4 square. So square root of 3 square is 9, square root of minus 4 square is 16. So we will get 25. So 5. So that is the magnitude of 3 I cap minus 4 j cap is 5. Clear? Okay. So note on this. Okay, so the question is, what is the unit vector of the vector P equal to 3 I cap minus 4 j cap? See, unit vector means the magnitude of the vector is 1 or unity. See, now unit vector of unit vector of any vector is that vector divided by its magnitude. So unit vector of vector P equal to vector P divided by magnitude of P. So now magnitude of vector P equal to magnitude of 3 I cap minus 4 j cap. So the magnitude of 3 I cap minus 4j cap is 3 square plus minus 4 square. So 3 square is 9, minus 4 square is also 16. So you will get 25. Magnitude is non-negative. You have to take 5 only, because square root of 25 you can write plus or minus 5. But the magnitude is always positive, so you have to write it as plus 5. So now p cap is the unit vector of p, vector p, as magnitude of divided by magnitude of p, vector p divided by magnitude of vector p. So vector p is 3a cap minus 4j cap, and magnitude of vector p is 5. So we can write 3 upon 5 I cap minus 4 upon 5 j cap. Okay, so this one is the unit vector of p, or unit vector along the direction of p. Okay, so note down this. Okay, the next question is, for what two angles of projection the range of the projectile is same? Okay, see, we have already known the range of the projectile is r equal to p naught square sin 2 theta divided by z. Okay, or also we can write this as 2 v naught square sin theta into cos theta divided by z. See here, just by interchanging theta with the 90 minus theta, only this sine function becomes cos and cos function becomes sine. Again we are getting the same expression. So therefore theta and 90 minus theta are the two angles of projection to getting the same range. So for example, if the angle of projection is 30 degree, so this one is the 30 degree, and if the object is projected with the same speed with an angle 60 degree, so this one is for 60 degree, we are getting the same range. R is same, the range is same. Similarly, if the first angle of projection is 20 degree and in second case the angle of projection is 70 degree, okay, in both cases the initial speed is same, so then also we are getting the same range. So generally we can say theta and 90 minus theta are the two angles of projection to get the same range. Okay, thank you.